Another important problem that we need to be able to solve is compound shapes or composite shapes that have zones taken out of them or taken away from them. And we can see examples of that here. This is a triangle, but the area of a square of a rectangle has been removed from it. This is a rectangle, but the area of a triangle has been removed from it. And the base, the final one, is an area of a rectangle where a small trapezium has been removed from it. And that's the first step in really solving these problems, is working out what we have and how we can calculate the value of it, what it was originally as a whole, and take away the shape that's missing to solve for the composite shape area. So in this first one, we can see we have been given a small rectangular chunk taken out of a larger triangle. So we need to solve for the area of the small rectangle and for the triangle. The first thing we need to do is work out the original dimensions of the triangle. So the original dimensions of the triangle were this 17, but also add on 3 for this distance here. So the total will be 17 plus 3. So this distance all the way down is going to be 20 meters. And this distance across is going to be 20 plus this 6 meters here. So this total distance is 26 meters. Now, to solve for the area of a triangle, we remember that the area of a triangle is equal to it's equal to half times base times perpendicular height. And in this case, that would be half times the base, which is 26 meters, times the perpendicular height, which is 20 meters. And that works out to be 260 meters squared. Now we just need to solve for the area of the rectangle. So, of rectangle. Well, in this case, that's going to be 3 times 6. 18 meters squared. So that's the area of the two shapes, but what we need to do now is realize that what we've calculated is the area of this whole rectangle as if the chunk hadn't been taken out of it. Now we need to remove this chunk. 1 second. So we just need to remove that chunk, which was the 18 meters squared. So the area, the total area, is going to be equal to 260 meters squared minus 18 meters squared. And that is going to equal 242 meters squared. Now let's look at the next one. What we have is a rectangle, which we can solve for the total distance quite easily. But we need to find out what this chunk here is going to be, what the missing amount is going to be. So to do that, we need to use the information we have to work out what the dimensions of this triangle would have been. So we know that this distance here to here is 6 meters. And we know that the total distance along is actually 13 meters. So this whole distance, this distance here is going to be 13 meters minus 6 meters, which is going to be 7 meters. And similarly, this distance here is in total is 8 meters. But this distance here is 3, so the difference here is going to be 5 meters. So now we have our triangle and we have our rectangle. So we just need to solve for the entirety of this rectangle and then take away the area of this triangle. So our triangle is going to be equal to half times base times perpendicular height. In this case, it doesn't matter which one we use. Either one for base or height won't matter because multiplication is ultimately commutative. So half times 5 times 7, which is equal to half times 35. And that equals 17.5 meters squared. Okay. So, the next one thing we have to do is the area of our rectangle. Area of rectangle is going to be equal to length times breadth, which is equal to 13 times 8. And that is 13 times 8. 104 meters squared. But we're not done yet because we need to take away this amount from the total area of what a complete rectangle would be. And in this case, our area is going to be equal to 104 minus 17.5, which is going to be equal to 86.5 meters squared. And in our next one, we're going to look at this trapezium. So we have a rectangle and then we have a trapezium. If we remember, the area of a trapezium is going to be area of trapezium. Actually, I'll restart this and we'll just make some space. So the area of our trapezium is going to be equal to A plus B over 2 times perpendicular height. If you look closely, they've given you the perpendicular height at 3 centimeters, and they've given you the heights of A and B. If we look, A is going to be B. One is going to be 8 centimeters, and the other is the same length as the original rectangle, which is 19 centimeters. So this is going to be equal to 8 plus 19 over 2 times the perpendicular height of 3, and that is equal to 27 over 2 times 3. Which is 40.5 centimeters squared. Now, the area of the original rectangle is going to be equal to rectangle is equal to 19 times 16, which is equal to 304 centimeters squared. So with that 304 centimeters squared, the total area of this composite shape is going to be equal to, so total area is going to be equal to 304 centimeters squared minus 40.5 centimeters squared, which is equal to 263 centimeters. 263.5 centimeters squared. Alright, so as you can see with this example, it really comes down to seeing what the original shape would have been, the largest shape you could make, and then subtracting the simplest shape you can given the information that you have. just make sure that you remember the formulas for determining these shapes and that you understand how to apply them to the composite shape. Before we were adding, just make sure you remember to subtract these shapes. We're taking them away from the original shape.